vocab and important things that you need to know. Going through them one at a time. Right. Key terms. First one is abstraction. Abstraction is where you basically filter out unnecessary data, so you ignore things so that you can find a solution without having all the information in it. So you're basically removing, you're abstracting what you actually need to get done, and then you can add the data back to it later once it's working. Decomposition, it's breaking down a problem into smaller parts. That's decomposition. I should say to help you solve a bigger problem. That's why we do it. Sequencing is just the order of things. So the sequence of a program is important so you can make sure it runs in a logical way. That's the word sequencing and what that means. Iteration is just about looping, repeating processes and steps. That's all. And when we talk about selection, it's all about bits of code that do things only when certain criteria are met. So if statements and things like that. It selects when it does particular data based on criteria, or when it does a particular program based on criteria. So selection is choosing which part of the program it does and doesn't run based on criteria being met or not. And that's what selection is. Your next one is flowcharts. Now you probably have to make a flowchart. So these are the symbols you're going to really need to know. This one is the easiest one out of the lot. It's called the terminal, but it's basically start stop. So at the beginning and the end of your program, you write that. You draw whatever that is, a circly thing. Put start in at the beginning, and at the end you draw a circly thing and write end. Easy as. The next one you need to know is this, the square one. It's called a process. Basically any maths or anything that's happening in the background happens in a process. Alright. This one, the rhombus, I don't know, my shapes aren't great. If you're asking the user to input info, it goes in a your question goes in the rhombus, or if you're printing something out, it goes in the rhombus. Right? And this one is a decision. That's an if statement or a while. Now, decisions have two roots. If the value is true and if the value is false. Alright, they're your four that you need to know. The line is just connect them up in the order you want it to do. Always start with start stop, so it's only really three you need to remember. The rhombus for input and output, so printing on questions. The diamond is for decisions, so if statements, and that'll have usually more than one lead off it. And a process is for everything happening in the background, like maths. So is number bigger than whatever, or times 2 by 4, or whatever it is that's happening in the background. Next one are different programming techniques. Now there's a range of different things that you need to know about, so I'm going to go through a few. This one here is called concatenation. It's essentially where you're combining different data types together. So if I've got two strings, the word you and the word reds, I combine them together as a whole string to become you reds, and that's concatenation, combining different datas together, usually different data types, but in this case they're both string. Next one is operators, basically things that compare each other. Now I'll put a list here for you. The most common ones you're going to need to know is this one. Is it equal to, and it's just two equal signs. Is not equal to, so you'd put if not equal to, you'd put an exclamation mark and equals. Then all the rest you pretty much know. So less than or equal to, greater than, whatever. Then these are just arithmetic operators, so in other words maths, dead easy. Addition, subtraction are the same. Multiplication, remember, it's an asterisk. And then mod and div we've talked about before. Mod, remember, is also a percentage. And then div is a floor division is a double division, like that. That's it really. Exponent is to the power of, and it's like a little one of them. The next thing you need to know is this, the random number. If you can remember it, great. If you can't, you're going to lose 1 or 2 marks max. But basically, to find a random number, all you need to remember is you put random, and then you choose your range. But it's usually rand.int, and then your range there. So random number. But if you put a range, you can also put words in. Doesn't make any difference. But essentially, you're going to print it. And then this is how you print out any random number between 1 and 10. And that's just the command. If you can remember, but it's just random dot rand int, then your brackets and whatever your range is. So between 1 and 100, it'd become 100, and that's it really. That's a random number generator. SQL is a language used to communicate with databases. This will only be 2 or 3 marks max if you even get it. But it's a language between usually websites and databases, but it's a query, which is a question, basically a language to ask questions of a database. The commands are always written in block capitals in this, and the only 3 commands you really need to know is select, from, and where. All right. Basically, select is the data you're looking for, the info you're looking for from a database. Right. So we say select this data. In this case, this is the most common one to use. So if you're in doubt, use this one. This is called a wildcard. It's just an asterisk. So select wildcard data from, and then this is the database you're looking from. From in our case, look, it's called customers database. Where the username, so this is your next one, the connective, so where this criteria is equal to, and in my case, I'm looking for the name Big Shaz. All right. So basically, this bit of SQL says select the data from the customer's database where username is equal to Big Shaz. But my 3 SQL commands are select, from, and where. Now, defensive design, loads of info on this, but essentially it's protecting forms and things from misuse. Most common way is authentication, so needing a password, a username, things like that. You can do something called input sanitization, which is basically where you use blocks and things to stop certain characters being entered, like an asterisk, as we saw from the last slide, being entered. It might also require you to enter certain information. So for instance, if you try and type in an email and you don't put an at, it won't let you do that. That's called input sanitization. In other words, stopping people just putting anything into the input boxes on things like websites. Other things to be considerate of when we talk about maintainability of a code or a program, I should say, it's things like adding comments. So a hashtag here, anything you write after a hashtag is a comment. In other words, people can read it, but Python doesn't action it, ignores it. All right. If we use functions and subprograms, it stops us having to repeat program. It makes it easier to maintain the program because we only need to write it once, test it once, and then if it works, we can use it throughout. So using subprograms and functions rather than repeating things helps maintainability. And then using consistent naming conventions. In other words, using underscores in between words or capital letters to signify the start of a word, because we can't use spaces. So either using like first name with capital F and N or first underscore name, and using those consistently, that helps maintainability. Language. Now there are different types of programming language. Computer-based language we need to know about. The first one is a high-level language. Basically uses words. That's it. Long story short, it's human-friendly. So like Python. There you go. That's your first one. The next one is a low-level language. There are 2 types that we need to know about. It's not as human-friendly. The first one is machine code, which is basically binary, and the other one is assembly language, which is like LDA, STR, like really short notations. Computers love low-level language, and they convert our high-level language into low-level language. All right, that's the first bit in the languages part that you need to know about. How do they convert it? I hear you cry. I'll wait for you to cry it. I assume you all did. The translator is the part of the program that does it. All right, so it's basically a computer program that just translates. High-level language we know. So a translator's job is to take this and turn it into this so the computer can understand it. That's what a translator does. Now there are 2 types of translator, a compiler and an interpreter. Right? A compiler translates the whole program at the end and that's it. All right? Whereas the interpreter does it instruction by instruction. So it does line 1, line 2, line 3, line 4. So compilers are quicker but more error prone. Interpreters are a bit slower but usually a bit more effective. Right? That's the difference between a compiler, which which is a type of translator, and an interpreter, which is an interpreter does it line by line, just like a spoken word interpreter. It'll do it line by line. That's the way to remember that. Right, IDEs. An integrated development environment is basically the bit where you can run your program. That's kind of it. In Python, we have the one called idle. All right. Within an IDE, an integrated development environment, there are a series of features. The first one, the editor, so you can actually write your program. You can write and test it and run it. There's something called error detection. So if I've got a syntax error, it tells me that I'm an idiot and I've got a syntax error. So there's error detection in there too. There's something called a runtime environment, which is a fancy way of saying a place where you can see your program working. That's in an IDE as well. And then, of course, the translator, where it converts our high-level language, say Python, into machine code. So all four of those parts appear within an IDE. And that is you prepped for your test.